So if you recall, the key to these problems, for adding and subtracting at least, is that you have to have the same name. That comes down to common denominators. Now, as you can see here, these two do not have a common denominator. They're different. Just like with numerical fractions, one of the ways we could find those common denominators is to factor. We saw that you could use factoring to find that least common multiple or least common denominator with numbers. We can do the same thing with algebraic fractions. So we factor x squared plus 5x plus 6 becomes what? Perfect. X plus 2 and x plus 3. X squared minus 4 becomes x plus 2 and x minus 2. Okay. It's a sum and difference product. So both of these have x plus 2 in them. This one has x minus 2. This one needs to have that. So we multiply by x minus 2 on bottom and x minus 2 on top. This one has the x plus 3. This one needs, the second one needs to have the x plus 3 in it. So we multiply by that on bottom here and on top as well. So now we have to multiply out 3x minus 1 times x minus 2, which will be 3x squared minus 7x plus 2 over x plus 2, x minus 2, x plus 3, plus 2x plus 5 times x plus 3 is going to be 2x squared, plus 11x plus 15. Again, you would just do the FOIL to get that if you aren't sure how I got those. And that's also over x plus 2, x minus 2, x plus 3. Any questions on how I made it this far so far? Okay. So now we have to add. So we're adding here. We're going to add like terms. 3x plus 2x squared is 5x squared. Negative 7x plus 11x is positive 4x. And 2 plus 15 is 17. Is that factorable at all? It's ugly to try, but yes, it makes it easier that it's 17 because 17 is prime. So it's only 1 in 17. There's no way to combine that with the 5x squared to give us that 4x. So no, that cannot be factored. So it's that over x plus 2, x minus 2, x plus 3. Now, did my math lab make you multiply that denominator back out, or did it let you leave it like that, factored? It lets you leave it that way? Okay. Now, for number 2, it's division. So the first thing we have to do there is rewrite it. And we're going to rewrite it as multiplication, which means we take the reciprocal of this second fraction. We flip it over. So that'll be x squared plus 8x plus 16 over, oops, it would have made that a lot easier to do if I'd have wrote that top fraction correctly. Hopefully none of you spun your wheels on that one for too long because you couldn't have solved it. So over x cubed minus 2x squared minus 35x. So we need to factor. We're going to start here with this first one. How do we factor that? We can factor out a 7x, which will leave us with x plus 5. So that is fully factored. Well, we just will jump down here. X squared plus 7x plus 12 factors to become x plus 3 and x plus 4. Very good. Let's go up here. X squared plus 8x plus 16 factors to be what? Yes, that is a perfect square trinomial. So it could be just x plus 4 squared. We're going to write it as x plus 4 times x plus 4 just because it's easier to cancel out factors that way. Now for this one here, we should first factor out an x to get that. Then what does that factor to? Perfect. X minus 7, x plus 5. Now we can start canceling. We can cancel this x and this x. We got x plus 5 and x plus 5, x plus 4 and x plus 4. So on top we have 7 times x plus 4. On bottom we have x plus 3 times x minus 7. Any questions? I know it's been a while ago. Does anybody have any questions off the homework from 2 weeks ago or the quiz that we did that they would like me to go over? Okay, well then it's time to hit our next step. And we looked at this a little bit before we left for spring break, looking at rational equations. And rational equations are nothing more than equations that have fractions in them. And there are a lot of different forms of rational equations. Could be as simple as this. We'll go 3x minus 5 divided by 8 equals 2. And to solve that rational equation, there are a couple of different ways I could look at this, but the steps to solve it pretty much end up being the same either way. I could look at this at what's been done to our variable. If I use my order of operations to list them out, first thing that's been done to x is x has been multiplied by 3. Then 5 was subtracted from it. Then the whole works was divided by 8. So I could look at that, and now to take it apart, we just reverse the process. We take off the last piece first. However, we want to look at this as more of a unified approach that we're going to use on all rational equations. And what we're going to do is we're going to look at, again, finding common denominators. And we're going to use those common denominators to eliminate the fractions in the equation. Now in this case, there is only one denominator, which is 8. So to get rid of that denominator, I'm going to multiply this whole fraction by 8. So I have to do each piece. This counts as all one piece at this point because it's all together. We can't separate it. So I have 8 over 1 times 3x minus 5 over 8. Now one thing, it usually helps if you think of that numerator as being in parentheses. But we can cross cancel the 8's to get 1 and 1. That's simply going to be 3x minus 5. Our next piece then is going to be 8 times the 2. So we've got the equal sign in there. 8 times 2 is 16. That becomes 3x minus 5 equals 16. How do we solve that? We add 5. 3x equals 21, and then divide by 3. So x equals 7. They can get more complex than that. We may have 4x over 5 plus 3 over 10 equals x over 2. So to solve this, I again need to find common denominators. And generally I'm looking for the least common denominator, but any common denominator will do. I have denominators of 5, 10, and 2. What's going to be the least common multiple or least common denominator for those? Well, both the 5 and the 2 go into 10, right? So the 10 will do it. Yep. So if I multiply that whole thing by 10, I'll get rid of the fractions. So 10 over 1 times 4x over 5. Cross cancel the 10 and the 5, giving me 1 and 2. 2 times 4x is 8x. Then I've got the 10 over 1 times 3 over 10. The 10's cross cancel, that just gives me 3. Equals the 10 times x over 2, so 10 over 1 times x over 2. Cross cancel the 10 and 2 gives me 1 and 5. 5 times x is 5x. And now I simply have to solve this. Normally, since I have an x on each side, I would get rid of the smaller one. I could still do that here, but that would leave me with 0 on the right side over here. So I'm going to get rid of the 8x over here, subtracting 8x. I got 3 equals, what's 5x minus 8x? Negative 3x. And finally, we'll divide by negative 3 to get negative 1 equals x. What do you think? Not so bad? Better than a sharp stick in the eye? Well, we could keep stepping up from there. We could run into two x minus 3 over 4 plus 4x plus 1 over 6 equals 3x plus 5 over 3. So I need to find, I have denominators here, 4, 6, and 3. What is my least common denominator for the 3 of those? Good. 12 is the smallest number that all of those will go into. So I'm going to multiply this thing by 12. So 12 over 1 times 2x minus 3 over 4. Now again, it usually helps if you just put parentheses around the top of that fraction, that rational expression, so that we don't screw up when we multiply. Now 12 and 4 will cross cancel. 4 divided by 4 is 1. 12 divided by 4 is 3. Now I multiply that 3 times the 2x minus 3. 3 times 2x is 6x. 3 times negative 3 is a negative 9. Now we move to the next term. 12 times the 4x plus 1 over 6. So 12 over 1 times 4x plus 1 over 6. Again, we'll picture parentheses around that. 12 and 6 cross cancel. They both divide by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. And we multiply. 2 times 4x is 8x. It's positive, so I put a plus in front of it. 2 times 1 is 2. Equals. Finally, we multiply the other side. 12 over 1 times 3x plus 5 over 3. Again, I'm going to put in those parentheses. 12 and 3 can both be divided by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So 4 times 3x is 12x. 4 times 5 is 20. So now we've eliminated all the fractions. It's time to start solving the equation. What would we do first here? Combine like terms. 6x and 8x make 14x. Negative 9 and positive 2, minus 7. Of course, that equals the 12x plus 20. What's next? Get x, perfect. Get x on one side by subtracting 12x. So 14x minus 12x is 2x. We still have the minus 7. That 12x is gone, so on the right side, all we have is 20. And then add 7. So that's gone. We got 2x equals 27. Finally, divide by 2. X equals 13.5 or 13 and 1/2. Any questions there? Well, they can get a little bit more complex yet. We can run into things like this. Now here you'll notice all of our variables are in the denominator. We have denominators of 5x, 2, 10, and 2x. When we are looking for our common denominator or common multiple, we can treat the numbers and the variables separately. So for numbers, I've just got 5, 2, and 10. What's the least common denominator or least common multiple for 5, 2, and 10? 10. Very good. For the variables, remember, we take the largest power. That's just going to be x to the 1, or just x. So our least common denominator, or least common multiple here, is 10x. So we'll multiply this whole equation by 10x. (10x) times 7 over 5x. We make that 10x over 1 times 7 over 5x. Some people like to cross cancel, others like to just multiply it out and divide. It doesn't matter which. Since I cross canceled on the last one, this one I'll multiply out and divide. So 10x times 7 is 70x. 1 times 5x is 5x. The x's divide out. 70 divided by 5 is just 14. We move on to the next term. 10x times 9 over 2, so that's 10x over 1 times 9 over 2. (10x times 9 is 90x. 1 times 2 is 2. 90x divided by 2 is just 45x. That brings us to the equal sign. (10x times 3 over 10). So 10x over 1 times 3 over 10. 10x times 3 is 30x. 1 times 10 is 10. Of course, 30x divided by 10 is 3x. Now this next one we've got to be a little careful with because it's a minus here. So we've got 10x times a negative 5 over 2x. So 10x over 1 times, we get a negative 5 on top over 2x. Remember that negative can either go with the numerator or the denominator. It just cannot go with both. I chose to put it with the numerator. So now I multiply this out. 10x times negative 5 is a negative 50x. 1 times 2x is just 2x. If I divide that, the x's divide out. Negative 50 divided by 2 is negative 25. Now we've eliminated all of the fractions. Is there anything we need to combine on either side? No, everything's combined. Is the variable on only one side? No, so what do we have to do? Subtract 3x. So we now have 14 plus 45 minus 3 is 42x equals a negative 25. What's next? Subtract 14 to get x by itself. 42x equals negative 39, and then divide by 42. X equals a negative 13/14. Now, if you're wondering how I got to 13/14, negative 39 divided by 42 can be just treated as negative 39 over 42. Both 39 and 42 can be divided by 3 to give me 13/14 or negative 13/14. What do you think? Not too bad? Well then, let's keep going. Our denominators can become more complex. Here, instead of just a simple 3x or 5x or whatever for a denominator, we have x plus 1. Sometimes, like in this example, that doesn't complicate things too much. The reason it doesn't is when we try to factor stuff here, that numerator actually factors into what? X plus 1 and x minus 1, which means x plus 1 cancels out. We have x minus 1 equals 0. We could solve that. How would we solve that? We would add 1, yeah, to get x equals 1. Now, we'd said once before that whenever there's an x squared in an equation, that means there's two answers. But we also said sometimes not all those answers work. The other approach we could have taken to this equation, to be consistent with what we've been doing, would have been to multiply by that denominator of x plus 1. If we do that here, the x plus 1s would have canceled out, would have left us with x squared minus 1. What's x plus 1 times 0? 0. So we would have had x squared minus 1 equals 0. If I want to solve that, I could factor that in x plus 1, x minus 1, but I'm going to take it easy on myself. I'm going to add 1 to get x squared equals 1. Then what? Square root. The square root of x squared is just x. The square root of 1 is 1. Okay. Give me just a second here. The square root of x squared, of course, is x. The square root of 1 is 1 or negative 1. Well, up here we only got the answer of negative 1. The reason, you got the answer of x equals positive 1. Is x equal negative 1 a solution? Well, I'm going to tell you it's not. Can anybody tell me why it's not? If we put x equals negative 1 back in this original problem, what do we get? Yeah, negative 1 plus 1 is 0. We cannot have a denominator of 0 because we cannot divide by 0. Dividing by 0 does very bad things. So in this case, x equals 1 is the only solution. Well, let's look at one a little bit more straight up than that. Let's look at this one. What is our common denominator? Well, we could multiply this out, but why bother? Our common denominator would be x minus 3 times x plus 3. When we go to multiply that out, we multiply times the 1 over x minus 3, what's going to happen? The x minus 3 and x minus 3 cancel out. What are we left with? X plus 3. When we go to multiply by the 1 over x minus or x plus 3, the x plus 3's cancel out. Now we have to be careful. This is a negative 1 times x minus 3, which is going to give us negative x plus 3. Good. Equals, now on the other side we are going to have to multiply this out. What's x plus 3 times x minus 3? Perfect. It's a sum and difference product, so we get the difference of perfect squares. So it's x squared minus 9. 2 times x squared minus 9 gives us 2x squared minus 18. Well, now what? Well, I can combine over here. What's x and negative x do? Cancels out. 3 and 3 makes 6. Now there's an x squared here. I could get everything on one side and make it equal to 0 and factor. But I don't have to because it's just the x squared. There is no x. So I can go ahead and just use that square root principle here. I'm going to add 18 to get 24 equals 2x squared. And then I'll divide by 2. To get 24, or sorry, not 24 now, but 12 equals x squared. And of course, the next step is to square root. For right now, we'll leave that as x is the positive or negative square root of 12. Well, since we're having so much fun, let's try this one. I have denominators of x plus 4, x minus 4, and x squared plus 16. Just like with the numbers, the first thing I want to check is to see if the smaller denominators divide into, that was x minus 16, x plus 16. To see if the smallest denominators divide into the larger one. Well, x squared minus 16 can be divided by both of those, can't it? It can be divided by x minus 4 and x plus 4 because x squared minus 16 is just x plus 4 times x minus 4. So x squared minus 16 is our least common denominator. We need to keep in mind as we do this, though, that x squared minus 16 is x plus 4 times x minus 4. Because as we see in this first step, we multiply by 1 over x plus 4. The x plus 4's divide out, leaving us with x minus 4. Good. The next piece, we multiply x squared minus 16 times 1 over x minus 4. There, things divide out to leave us with x plus 4. Good. The x minus 4 and x minus 4 divide out. On the other side, we do x squared minus 16 times x squared minus 48 over x squared minus 16. What happens there? The whole thing cancels out, right? X squared minus 16 cancels out itself to give us x squared minus 48. Now what? We combine over here. X and x make 2x. Negative 4 and positive 4 make 0. What's our next step? So we'll subtract 2x from each side. Why did I subtract the 2x? Because remember, x squared here is already positive, so I'm going to leave that where it is. I subtract 2x here to get 0 equals x squared. Perfect. Does that factor? What do we get? Perfect. X minus 8 and x plus 6. Any questions on how we got that factoring? Remember, it multiplies to x and x multiply to make x squared. Negative 8 and positive 6 multiply to make negative 48. And if I do the outside and inside check, x times 6 is 6x. Negative 8 times x is negative 8x. That adds to be negative 2x, which is what we wanted here. So now that we know that that's how it factors, what do we do with it? Perfect. If they multiply to equal 0, at least one of them equals 0. I don't really need the parentheses over here. So then I'm going to solve this one by adding 8. Gives me x equals 8. Or this one by subtracting 6. Gives me x equals negative 6. We should double check in our equations to make sure those give solutions. So x equals 8. Let's go back to our original equation. So if x equals 8, this becomes 1 over 8 plus 4 is 1/12. This becomes 1 over 8 minus 4 is 1/4. Eight squared is 64 minus 48. This will be 64 minus 16. 1/12 plus 1/4 is 1/3. 64 minus 48 is 16. 64 minus 16 is 48. 16/48 does reduce to 1/3. So the 8 works. Let's try negative 6 to make sure the negative 6 works. So if I put negative 6 in here, 1 over negative 6 plus 4 is negative 2. So that's a negative 1/2 or 1 over negative 2. Plus, if I put in negative 6 here, 1 over negative 6 minus 4 is negative 10. So that's a negative 1/10. Negative 6 squared is 36 minus 48. This will be 36 minus 16. Negative 1/2 plus negative 1/10 is negative 3/5. 36 minus 48 is a negative 12. 36 minus 16 is 20. Negative 12 over 20 does reduce to a negative 3/5. So both of those solutions work. Any questions? I can see by the looks on your faces you're just jumping to try one of those for yourself. So let's give you one here to try in your notes. I'll give you a few minutes to try that one. Let's go 4 minutes. So what you find is your common denominator. Perfect. The 2x squared minus x minus 3. And we have to make sure we keep in mind that that is 2x minus 3 times x plus 1. So when we multiply this first piece here, what's left? X plus 1. When we do the second piece, what do we get? Perfect. We have to remember it's a negative 1 times it. The x plus 1 cancels out. It's negative 1 times 2x minus 3. So negative 2x plus 3 equals 1. So now we've got x and negative 2x make negative x plus 4 equals 1. And then subtract 4 to get negative x equals negative 3, and then we divide by negative 1 or multiply by negative 1, it doesn't matter. X equals 3. I made that one almost too easy for you, didn't I? Well, let's look at some other examples here. I want you guys to try this one. Give that one a try quick. I'll give you a little over a minute for that one. What is our common denominator for this one? 12. Good. When we multiply the first one, 12 and 6 cancel to give us 2, so we are left with 2x squared. Good. Multiply the second one, 12 and 4 cancel to give us 3, so that leaves us with 3x equals, and then 12 times 5 over 12 is 5. Now what do we do with that? We subtract 5 to make it equal 0. So we got 12x squared plus 3x minus 5 equals 0. And then does this factor? What do we get? Two x plus 5 and x minus 1. So now we have two equations to solve. 2x plus 5 equals 0, or x minus 1 equals 0. Here we're going to subtract the 5. 2x equals negative 5 and divide by 2. X equals negative 2.5. Over here I can add 1. X equals 1. So either x is negative 2.5 or x is 1. Any questions on that one? Why don't you try this one? Four over x minus 7 over 5x equals negative 1/2. I'll give you a minute or so on that one. What'd you get as our common denominator here? 10x, good. So 10x times 4 over x? 40. The x's cancel. 10 times 4 is 40. 10x times a negative 7 over 5x? Negative 14, good. And then 10x times a negative 1/2? Negative 5x. So of course we're going to combine 40 and negative 14, make 26 equals negative 5x, and then what? We divide by negative 5, yes, and x is negative 5 1/5. Any questions? Well, let's go up one more notch. I'm going to have you try, well, I'm going to do one here, and then I'll have you guys try one. So I'll do 5 over x plus 2 plus 2 over x squared minus 6x minus 16 equals 4 over x minus 8. So, if we look at this, x plus 2 times x minus 8 is x squared minus 6x minus 16. So our least common denominator here is going to be x squared minus 6x minus 16. But again, we're going to keep in mind that that is x plus 2 times x minus 8. So that when we multiply this through, multiplying the first piece here, the x plus 2 part will cancel out. This is just x minus 8 times 5, which is 5x minus 40. We multiply the second piece, the whole thing cancels out. X squared minus 6x minus 16, so we're left with just a positive 2. On the other side, we multiply by the 4 over x minus 8. This time the x minus 8 cancels out, leaving us with just x plus 2 times 4, which is 4x plus 8. Now what would we do to solve this? Combine here, so we got 5x minus what? Minus 38. Now there's x is on both sides, so what do we have to do next? We'll subtract 4x to get x minus 38 equals 8. And then add 38. So x equals 46. Not so bad. Well, time for one for you guys to play with. Give that one a shot. I'll give you about 3 minutes. So the common denominator here is going to be found by multiplying x plus 1 with x minus 1, which of course is just x squared minus 1. We multiply the 3x minus 2 over x plus 1. The x plus 1 cancels out, so that's just going to be x minus 1 times 3x minus 2. That's going to give us 3x squared minus 5x plus 2. Does that look right? Moving on to the next one. X squared minus 2 times 4. That's 4x squared minus 4. The next one, x squared minus 1 times x plus 2 over x minus 1. The x minus 1 cancels out. That's going to be x plus 1 times x plus 2, and we can't forget it's multiplied by negative 1. So that's x squared, 3x, and 2. It would have been plus, but multiplying by negative 1, it becomes minus x squared minus 3x minus 2. Does that look familiar so far? Any questions on how I got any of this so far? Okay, so on the left side, there's nothing to combine. So that's going to stay 3x squared minus 5x plus 2. On the right side, 4x squared minus x squared is 3x squared. Have the negative 3x. Negative 4 and negative 2 is minus 6. Our next step is to get everything on one side if we need to. But we actually notice that when we go to get the x squared on one side, we subtract 3x squared from both sides and it disappears. We now have negative 5x plus 2 equals negative 3x minus 6. Now I would get rid of the smaller of the two x's since there's one on each side. Negative 5 is smaller than negative 3, so I am going to add 5x to get 2 equals 2x minus 6. Now we just solve by adding 6. 8 equals 2x, and dividing by 2. 4 equals x. Not so bad? Okay. Well, there's a subdivision of these problems that can be solved a little bit simpler than what we've been doing. That subdivision is what we call proportion problems, where you end up with something like this. And in this case, there's one fraction on each side of the equation. So we don't need to go through a whole lot of all that whole works of finding the common denominator. What we can simply do here is cross multiply. Remember, the cross products of a proportion have to be equal. Since this is one fraction equals another, this is just a proportion. So going in this direction, we have 25 times x is just 25x. Going in this direction, I would do 5 times 3 is 15 times x plus 2 is just 15x plus 30. Now what would I do to solve that equation? Subtract 15x. 10x equals 30. And then divide by 10, x equals 3. Notice that's a lot simpler than trying to find a common denominator. And even some problems that look really ugly can be greatly simplified using that strategy. Finding a common denominator here would not be pleasant. It would be 3 plus 6 over x, but that's even multiplying by that would really be a nightmare. But we can do that cross multiplying. If I multiply in this direction, I have 3 times 1 plus 4 over x. That multiplies to be 3 times 1 is 3. 3 times 4 over x is 12 over x. Think of that as 3 over 1 times 4 over x. You get 12 over x. Going in this direction, x times 1 plus 2 over x. It's actually even simpler. X times 1 is just x. X times 2 over x is just 2. Now we still have a little bit of work to solve this equation. What are we going to have to do here? Multiply the whole equation by x. Good. So now we got x times 3 is 3x. X times 12 over x is just 12. Equals x times x is x squared. And x times 2 is 2x. We need to get everything on one side. Since there's an x squared and an x in here, we need to get everything on one side and get equal to 0. This is our x squared, and it's currently positive, so we're going to move everything to that side. So I'm going to subtract 3x, and I'm going to subtract 12 from both sides. So 0 equals x squared. 2x minus 3x is negative 1x, or just negative x, and minus 12. That will factor into what? X minus 4, x plus 3. So of course that gives x minus 4 equals 0, or x minus 3 equals 0. We can add 4 to both sides to get x equals 4. Here we can subtract 3 to get x equals negative 3. So x equals 4 or x equals negative 3. You would want to try those back in the equation to make sure. But for now, we're running low on time, so we're going to leave it at that. So the stuff we covered today is in homework 9A out there in my math lab. If you have not turned in corrections for test 1 yet, you have until the end of next week to do that, because remember, 2 weeks from today is test 2. If you have any questions on those corrections, please let me know. Okay, well, you guys have a great day. We'll see you tomorrow.